Okay, now we move to statistics. Any questions so far? You know what I'm talking about when I say data? Text data, time series data, qualitative. Qualitative, you have nominal, ordinal. Quantitative, numerical, you have discrete and continuous. Interval ratio is also there. Clear?
Yeah.
Yeah, and this is important. Okay, this is basic because the analysis that you'll be performing, okay, in your project work, or in occasion maybe in future you'll be working on this. So analysis, you know that when data, based on the data only, you will decide what kind of analysis you can perform, right? If I have a descriptive data, I can't draw a scatter plot. If I have a text data, I can't draw a scatter plot. Okay, so you need to know, okay, if this data is there, I need to perform this kind of operation, this kind of analysis I will be performing. Okay, so I'm going to talk about, towards the end, I'm going to talk about some of those analysis that can be performed. But first, let's understand the statistics behind it. Okay. Okay. So statistics also, there are two types of statistics. What are those types of statistics?
Quantitative and qualitative.
Right. So you have descriptive, okay, and you have inferential statistics. Descriptive, okay, is you're describing the current situation. Okay. So in descriptive, since you're describing, you need all the information, right? So if you have to describe the performance of students in a class, if you're describing the performance of a company, if you're describing performance of all the companies in a country, right? So here you need all the data, right? And data can run into thousands and hundreds of thousands and millions, doesn't matter, right? So you need all the data. Okay, so descriptive is where you have access to all the data, and then you perform your analysis. You can perform histogram, bar graph, all those analysis you can perform, and then you say, okay, looks like this year we have done better than last year, right? So if you have to know how well you are doing this year than last year, it's okay. Let's look at the January sales of this year versus January sales of last year, and you see that January sales this year is higher than last year. You say that, okay, this year we have done better, right? In descriptive statistics, you have all the data and you play with all the data, whatever be the size. Okay, it could be 10 rows or 10 data, or you have millions of rows, okay, millions of data to work with. Doesn't matter, size doesn't matter, but you need to have all the data to know, okay, to perform your analysis, right? The second type of statistics is called inferential statistics. In inferential statistics, okay, based on some limited data, you will have to make prediction for entire what we call as population. So you have concept of sample and population. Sample is what you have access to, right? You might have access to only 100 data, but based on 100 data, you have to make data, prediction for 1 million, data, which is not possible to get. Okay, the reason we do prediction is, one, we cannot have access to entire data, right? So if you want to talk about what people think about your product, right? You're a marketing company, you're marketing head of a company, okay, and you want to know, you want to know, like what people think about your product. Okay, let's say you think about your product, right? So now you'll have thousands of customers, but it is not possible to go to all the thousands of customers, okay, because you don't have enough time, right? If you go, if you start going to all your customers, it'll probably take a year to get all the data. One. Second thing, you may not have that much of budget, right? You need to have 10 people going and collecting data. It may not be possible for all the companies to do that. So you don't have time, you don't have money, okay? Sometimes it is not possible. You don't even know who are your customers, right? If you're selling in a retail store, you don't even know who your customers are, who have bought your product, right? So it is not possible, okay, for a variety of reasons to reach out to all the customers. So what you do, you reach out to only limited, 100 customers. And you interview them, you get the data from 100, and then you say, okay, Okay, 50% of customers like our product, 70% of customers have liked our product. Like you have not interviewed all the 100 and you're saying that 70%. Okay, you have interviewed few and based on that you're extrapolating. That's called inferential statistics. Okay, so inferential statistics, you have concept of sample and population. Population means the entire people, if it's possible. Okay, and the sample is the people who you have spoken to, have given you the feedback. Okay, so that's called inferential statistics. In descriptive, we have access to all the record. Okay, and we are making our assumptions, we're making our analysis, understanding based on all the records. So that's the difference. Okay, so what we're going to do here in this chapter is to understand what kind of metric we use. Okay, in this. Okay, now if you talk about the basic metric in statistics, we have mean, median, mode, right? And Keshav, do you know what is mean, median, mode?
Yeah, I do.
Yeah. Okay. So many times I'll ask Keshav because if Keshav says I know, so I'll assume that Gauri also knows, right? Gauri is in higher class. So if Keshav says no, I don't know, that's when I'll probably explain, okay, or ask Gauri, right? Because if Keshav says he knows, that means Gauri would definitely know, right? And I hope my assumption is correct, Gauri, right?
Yeah.
Yeah. So, okay. So, like for example, in descriptive, we have this basic metric like mean, median, mode. Now, if we are going to inferential, so you still have mean, median, mode. Okay, but your mean, median, mode will be two values, one for population and one for sample, isn't it? Okay. So, so we don't talk about mean, median, mode there. We talk about variance and standard deviation in there in the sense inferential statistics. Okay, so you'll have standard deviation for population, standard deviation for sample. Okay, two metric, right? Everything will be two copies there. Here only one copy, right? We have only one data set. We'll have only one copy. Okay, so it's called measure of central tendency. Central tendency means when you have a lot of data, right, with you, how far are the values from the center point, okay, or the average value. So we find mean is the average, right? And you say average comes to 70, let's say, for example. Okay, so how far are the minimum and the maximum values, right? Minimum can be 10, 20, maximum can be 100, 120, right? So, okay, so we are trying to understand how far we are from the mean. Okay, and one thing you understand, okay, is that the variability, okay, do you want variability in life or not? You tell me. Do you love if there's a lot of variability in your life? Or you want less of variability in your life? So, I hope you know what's the meaning of variability. Variability means you don't know when your class will start. Okay, sometimes teacher, your teacher will call you at 8 a.m. and sometimes they'll call you at 9 a.m. You don't know what time your classes are. You don't know what time your flight will take off when you going for a vacation, right? So on the flight they'll say 3 p.m. but till 4 p.m. there is no sign of the flight. Okay, you want to buy a new gaming toy for you, and they say, okay, we'll give you in 3 days. You go after 3 days, he says again 3 days, you go after again 3 days, again he says 3 days, right? So do you want variability in life or not?
No.
We don't want variability in life, okay? We want things to be, it can take time, okay? It could be, let's say, class can be at midnight 12 also, right? That is less painful than the variability because at least you know that class will start at midnight, whatever, you will probably sleep early or do something to make sure that you will be up and listen to the class midnight. But, variability is not what we like, okay? Variability is, when you talk about the business, when you talk about systems, okay, if there's a more variability, you cannot plan properly, right? If there's a class, there will be a class today and you don't know what time the class will be. So you can't plan, let's say, your outing. You can't plan your, let's say you want to go out and have dinner. You can't plan all those things, isn't it? Because you don't know when your class will start, when you get finished. Okay, so we need. Okay, so what is the opposite of variability? For now, let's talk about, we say that less variability, okay, or minimum variability or zero variability. Zero variability is not just, it's not possible, but at least you want it to be as close to zero. Okay, we want more certainty, not variability. Okay, so and so the process also, because the process is stable. Okay, then you can make plans. Okay, this is what we'll do, this is what I'll do. 1 o'clock class will start, 2 o'clock I'll go to picnic, 3 o'clock I'll go there, 8 o'clock I'll have dinner. You can plan all those things, but if there's a variability, you don't know when a class will start, class will finish, you cannot make any of these plans, isn't it? So what we do is, okay, and of course we're talking about from business perspective, isn't it? We want to measure how much variability is in the process. If the variability is zero, okay, not zero, but close to zero, let's say, then you will say, okay, this process is good, let it go like that. But if there's a lot of variability, right, one day you guys will stand and say, ma'am, or sir, please, give us a fixed time. Okay, you will see once or twice, and then you will start speaking, saying, this is not right. Okay, so you need to know what process is not right, so that you can fix it. Okay, so ultimately in business, we want to know which portion or which division or which team is not working, so that we can go and fix it. So this metric will tell you, okay, how bad is your process. Okay, so measure of central tendency. Okay, so average is 1. Okay, so you have talked about mean. You know what is mean, median, right, and mode, right? So these are central tendency. Okay, so this is what I think we were discussing about last week, isn't it? So if you see school A and school B, mean, median, mode is all around 70. School B, 43, 99, 65. So you see that school A, okay, students are more or less, same in their, okay, if I can compare marks with intelligence, so I'll say they are more or less of same intelligence level. They're getting all similar marks. But in school B, the variation is a lot, right? So maybe the student who is intelligent is very intelligent, and the student who is not intelligent, okay, on the lower scale, is very, very poor, right? But in school A, it looks like, everybody is equally good or bad, whatever you say. Okay, so so sometimes, of course, everybody wants to be better than the rest, isn't it? So school B, you'll have people who are better than the rest, but in school A, they're all part of equal, almost in same range. Okay, so you can see the data, right? School A, it is all like 70, 70, 71, 80, almost in same like 5 marks range. In school B, you have 30 as well, you have 99, 100 as well, right? Okay, so 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 this mean, median, mode tells us how good is your process. Okay, and process, when you say good, it means that it should have less variability. Okay, so generally process, when you say it's a good process, we say the process which is less variability is better, good process, and that process is which has a lot of variability. Okay, so you can read all these things. This is an example. Okay. So what it says is, branch manager, okay, he's getting complaint that customers, okay, are spending too much of time in, they are getting late. They are spending too much time for their banking work. Okay, so they want to understand. Okay, or not they. The branch manager wants to understand: is it really true, right? Okay, how much time people are spending in the queue? Okay, and how can he help, right? Just because people are complaining, he cannot hire couple of more people, right? He wants to see, is it really worth hiring more people for the job, isn't it? So what he did is he just he sat one day looking at the customers, and he's noting down the time when customer comes in for a work, and the time that customer leaves after getting the work done, right? So it could be seconds or minute, whatever, right? So let's say, okay, he has noted 420 customers. Let's say 20 customers came that day, and he noted the time of 20 customers. Okay, so this is table. Now, how do you analyze it? Okay, so you have 20 data. How do you analyze it, right? So when you have a lot of data, right, one way is that you create a histogram. So don't look at the individual numbers. Okay, you group them like a bucket. So here he has grouped them like say 30 to 35, 35 to 40, 40 to 45. Okay, and then he's having a count. Okay, so bulk of the customers, okay, you see, are getting service from 40 to 50 minutes, right? There are few customers, say 2 customers, are getting beyond 50, right? Now, 50 seconds, do you think is it more time or less time? If you think it's more time, then you know that, okay, most of the customers are spending more time, so you need to do something about it. But if just 2 or 3 customers are, is getting delayed, okay, out of 20, 1 customer getting delayed, probably this is not the right time to expand your work, right? So this is how we perform analysis, okay, a simple analysis. So 1 customer is waiting between 1 and 35 seconds, 5 customers 1 and 40 seconds, right? Only 2 customers are waiting beyond 50 seconds. If 50 is your, let's say, a cutoff time, okay? Let's say if you put 45, then 7 customers, 1/3 customers, not good. Okay, so this is an example where you will use histogram. Another example is the revenue, sales revenue versus the temperature, right? So here you have 2 data. Okay, if you're working on one population or one data, right? One data is the time, right? One data. Okay, it has to be numeric, right? It has to be on numerical, quantitative data first. Second thing, okay, if you have one data, then you will create histogram. When you have 2 data, okay, you will end up creating scatter plot. Okay, scatter plot gives you the relationship between x and y axis, right? So one value you will put on x axis, other value you will put on y axis, and you'll draw a scatter plot, and scatter plot will look something like this, what you see on the screen, right? So you see that, okay, the relationship between x and y. What is on x? On x you have temperature, and on y you have sales, right? So as the temperature increases, sales also increases, right? So we call it as correlation. Okay, correlation means that one factor is impacting the other factor. Okay, so here you see, we say that, okay, temperature and sales are correlated. If the dots were all over the place, you cannot find a relationship between. Okay, let me draw and show you. Okay, so let's say you have, okay, so this is temperature, and let's say this is sales, right? Now you have dots everywhere. Here you see, there is no way you can find that, there is a relationship between T and S. So we say that sales and temperature are not correlated. Sales and temperature are not correlated. Okay, because there is no trend. You can't see a trend. Okay, doesn't matter you have 100 data or 10,000 data. If you can plot, I see a graph. Okay, if you see a graph, there is no correlation between S and T. So here your scatter plot is not going to help much. But what we have is something like this, right? Something like that. So you see, as temperature increases, sales increases, right? So you see, there is a correlation between sales and temperature. Okay, so roughly, if you are a person who is selling it, you will look at the temperature or forecast for the day, right? If the forecast is that day will be cooler, you will carry less product to the store. You know that your sales will be less. So you are able to predict something which is not easy to predict, right? So you predict sales is not easy to predict, but you found a factor which is easier to predict because weather.com will tell you the temperature, okay, and the weather forecast for all the cities in the world. Okay, so something we can predict, not predict, you know what will happen tomorrow or day after. Sales you can't, but sales there is a not exactly you'll be able to find, but okay, today I'm going to make more money or you're going to make less money. Today, you have to carry more product, you have to carry less product. Okay, so you can look at the forecast for next 1 week and plan your inventory, the stock accordingly, right? So if there is a correlation, if there's a trend, correlation, we call it as positive correlation. So so we say, looking at data, you can say there is a correlation. Okay, yes, there's a correlation. If you increase temperature, your sales will also increase. There is a correlation. Okay, on the other side, okay, we say it is correlation and it is positive correlation. Positive correlation means, okay, both increases together or both decreases together. Temperature increases, sales also increases. Temperature decreases, sales also decreases. We call it as positive correlation. Okay, if one is increasing, other is also increasing. One is decreasing, other is also decreasing. So the relationship is positive. They go hand in hand. So we say T and S, temperature and sales, are positively correlated. Your regression algorithm, okay, is based on this concept. Okay, regression algorithm, machine learning is based on this concept. So we try to find out all the possible. Okay, so here, X generally, in mathematics we write y equal to something, isn't it? Y equal to m1 x1 plus m2 x2. So y will be 1 on left side, and x can have multiple x generally. That's how we write equation, isn't it? So both are something that you don't know. We need to find out, right? So we try. If we are able to find the value of x, you can find the value of y, isn't it? So y is something that you don't know. Okay, something that is difficult to predict, like sales of ice cream. But x is something you can easily predict. Okay, for some reason, okay, you can see on Google or somewhere, and you see, okay, oh, x is increasing, so y will also increase with this factor, right? So that's what we do in regression. Okay, so going back to correlation, we call this as positive correlation. If one increases, other also increases. One decreases, other also decreases. Then you can have something like this. So you see, T and S, T is increasing, S is decreasing. There is a correlation. Looking at the graph, you can still predict, right? Okay. Looking at the graph, we can still predict, right? But here it is negative correlation. That means if one increases, other decreases. If one decreases, other increases. Okay? So there is a reverse correlation between them. So we call this as inversely proportional or negative correlation. There is a correlation, isn't it? But it is negative correlation. Okay? So when we talk about regression algorithm, you will see that multiple variables will be involved. Here we have only 2 variables, right? So which is X and which is Y here? Can you guess? Sorry, can you guess? Okay, generally, what will put X and what will we put Y? Okay, it's not mandatory. Okay, it's not mandatory that it should be X only. But looking at it, can you tell? Yes. Sorry. Stop you midway. Yeah.
Isn't X temperature?
X is temperature, exactly. Okay. X is temperature and S is Y. Okay. It can be other way also, okay? But as per logic, as per notation, okay, the x-axis we put x, on y-axis we put y. Okay, why do we do that is temperature is something that you can find out from internet and other websites. Okay, so this is something that we can easily predict, we can easily find. So it is written on the right hand side. Okay, and sales is difficult to predict. Okay, so and what's your goal as a business, as a business person? Okay, your goal is not to predict the sales. Sorry, your goal is not to predict the temperature. Okay, your goal is to predict the sales as a business person, right? As a CEO or as a marketing manager, as an operations head. Okay, your aim is to find the sales. And so, okay, you can't find this, the value of sales directly. So you're trying to find other parameters using which you can guess. So parameters which are known, and based on that you can guess. Okay, guess is not the right word, predict. Okay, so that's why S is what you want to predict, and what you want to predict becomes Y. Okay, and in one business problem you'll be only finding one thing, right? Okay, so X is your Y. Y is always 1. Right? And at the same time, your sales can depend on multi parameters. One is temperature, and other thing could be whether it's a whether it's a Sunday or Monday, right? Weekday or weekends, right? So so another parameter could be your qualitative. Weekday, weekend is qualitative. Okay, categorical value, right? Okay, temperature is numeric. So you can have your numeric value, but Y is always numeric. Okay, when in such cases your S, okay, your Y is always numeric. When you're talking about regression or correlation, your Y is always numeric. Okay, okay, so Y has to be numeric. Your X can be numeric or so here you have numeric versus numeric. When you talk about weekday, weekend, it could be categorical value, right? So X can be either categorical or numeric, but your Y is always numeric in regression. Okay, so if Y is numeric, I have to use regression. I have to use regression. If it is not numeric, we use what is called as. If it is not numeric, that means it is categorical value, right? So if Y is categorical value, then we use classification algorithm. So there are two main algorithms type: regression and classification. Regression is when your Y is a numeric value. Okay, I want to find how much sales will I make today, or how much sales I'll make tomorrow, right? So that's a numeric. How much, how many, right? So that is numeric, and we use regression. Example of where Y is categorical can be: should I invest or not? Should I invest this or not? Should I buy? Yes or no? Yes or no? Right? Yes, no, maybe. Right? So it could be multiple class. Okay, we call it as two class or multi-class. Class means how many possible values are there. Okay, I want to know, should I buy it or not? Right? So here you have two values, yes or no. So we call it two class problem. Okay. Okay, which direction should I go? North, south, east, or west? Multi-class. More than two, we call it multi-class. 4 classes, a multi-class. Okay, here it is not numeric. How many steps should I walk? It is numeric, regression. Which direction should I take? North, south, east, or west? It is classification. Okay, if it is single population, we're talking about single population. Okay, not multi values. Okay, the output is only one. Okay, either numeric or categorical. So if it is numeric, we use regression. If Y is categorical, just like north, south, east, or west, yes or no, we use classification. Clear so far?
Yeah.
Okay, so the basis for all those is this, what you call as correlation. If there's no correlation, then you cannot predict. If the temperature and sales had no correlation, then even if you know the exact temperature value, you won't be able to predict the sales because sales is not impacting. But if sales is impacting, you can predict. It is impacting positively or negatively, doesn't matter, right? If it impacts positively or negatively, doesn't matter. As long as it's impacting, we can easily use our mathematical analysis and we can find the value and predict the value. Okay. Then again, in correlation, we come across a strong or weak correlation. Okay. Strong correlation means that the dots are very close to straight line, and we are very sure about prediction. Okay, weak correlation means you are not very sure. Okay. Yeah. Okay. We'll move to the next part. Okay, so I'm not going to talk about what is arithmetic mean, geometric mean. They have all different meaning. Okay, you can read them. Okay, what is best? Mean, median, or mode? Tell me, what do you think is the best? Metric: mean, median, or mode? What do you think?
Mean.
Mean. Okay, so first thing, mode is not very significant. So let's rule out mode first. Mode does not provide, it tells you which values are repeated maximum number of times, right? It doesn't tell us, what data, should be in normal circumstances. Okay, mode is same as mean and median, right? See, if mean, median, mode are same, then it doesn't matter, right? Which one, whichever you want, you can choose, right? But in case where if they are not same, they are different. Okay, when you say same, not in same range also. The gap is too much. In such case, mode we ignore. Okay, mode we don't consider. Okay, because mode doesn't provide any significant value to the statistical analysis. Okay, so mode generally are not considered. So now the fight is between mean and median. Okay, so what it says is, if the data is evenly distributed, okay, they may not be close to the center, evenly distributed, okay, then you can use mean. Okay, mean, median will be almost same. So okay, you can use either mean or median, right? So in such case, generally we use mean. But if data is not evenly distributed, okay, the example that you see here, graph. Okay, bulk of the data is on the left side. Less data you have on the right side. So this graph talks about the annual income of each household versus how many households are there. So lower the value, lower the income, more households you have. As you go across the higher values, okay, higher household income, the number of households are decreasing. Okay, is getting lower and lower. So this data is not evenly distributed. Bulk of the data is on the left side. Okay. So in such case, we use median. So median, okay, is more suitable. Okay. So median is more important than median mode. But even data is evenly distributed, right? If similar graph you find. Okay. So if you put a mirror, right? So it's like more like a mirror image. So if you put a mirror at the center, both the half would look similar, right? So if it's mirror image kind of graph, then mean is preferred. Okay, okay, because mean uses all the values to analysis. Okay, but median uses only the mid values. It doesn't use all the numbers to analyze, right? Median uses only mid values, right? But average uses all the values, isn't it? So that's why mean is better, in normal circumstances. But most of the time, situation is not normal, right? You will get situation like this, okay? which is in unevenly distributed data, right? In such case, median is preferred. Okay, so you should know when to use median, when to use mean. Okay, mode is not used. Okay, but median and mean are used very often. Okay, sorry guys. Okay, okay. Now, so this is done. I was talking about, yes. Okay, now we should also see, okay, skewed graph. Okay, now we're not going to talk about that, but you see, if it is not evenly distributed, there will be a tail at one end and tower at other end. Okay, so you'll have tail at one end, tower at other end. In this case, tail is on the right hand side. It is going in the positively x direction. So this data, this such graph is called positively skewed. If it is evenly distributed, it is non-skewed, isn't it? But if it is tail is going in the x direction, positive x direction, okay, it's going in the positive, tail is going in the positive x direction. We call it as positively skewed graph. If the tail was going on the negatively x direction, other way, okay, if the towers were on the right hand side and the tail was the left side, that means tail is going towards minus x axis. So we call it as negatively skewed. Positively skewed, negatively skewed. It is decided based on the tail, not on the tower. Okay. So this graph, okay, is not evenly distributed. So we will use median for analyzing the values. And this is example of positively skewed graph. Positively skewed graph. Yes. In text data, in categorical data, ordinal or nominal, their mode is preferred way to analyze the data. There we use mode to analyze. So in categorical data, in qualitative data, mode is used. In numerical data, mode doesn't play much important role. So we use mean and median. Mean is used when the data is evenly distributed, almost evenly distributed. Okay, mirror image kind of situation. We use mean, and median is preferred when data is skewed. Right? Data can be positively skewed or negatively skewed. Negatively skewed means the tail is going towards left side. Okay, towards minus x side. When you say positively skewed graph, your tail has to be going towards the positive x axis. Okay, so the graph that you see here is not, non-skewed. It is skewed. Okay, so it is positively skewed graph. Did you get it? 100% of what I said?
Yeah.
Okay, Keshav, if you're getting even 30-40%, it's okay, right? So, as you grow, as you work, you'll understand. But if you're getting zero, probably ask me or ask your sister. It will be revision for your sister as well. If you ask her, please help Keshav, okay? God, if she comes to you, okay? If Keshav comes to you, please help him, okay? So that way, you will also get practice and he'll also understand it better. Yes?
Yeah.
Good. Then you have weighted mean, weighted average, where we are seeing that you should know, you would have done this in your class, right? Weighted means where all the values are not equally, doesn't have equal meaning, right? Some values might have more than one, more important than other. Then we don't use simple mean, we use weighted mean. Okay, so this is an example you can practice. I did share this link with you, isn't it? PDF link?
Not yet.
Okay, so I'll do that after the session. Okay, so yeah, this is what I was talking about. Okay, these are all examples of symmetric histogram. Okay, non-skewed symmetric histogram. Mirror image. So in such cases, if your graph is coming like this, histogram is coming like this, you can use mean to analyze, right? But if your is skewed, this is, so center one is normal and the left side are skewed graph. Right, so in such cases, median is better option. Okay, because we don't use mean. The question would be, why don't you use mean? So if you have one out of sync data, right? Let's say most of the values are between 50 and 100. Okay, suddenly you get a data which is 5,000. The mean will run faster. Okay, because mean uses all the values for analysis. So mean will run faster than median. Median uses only mean values data, isn't it? So in such cases, okay, mean will be far. That's why you see mean is always far away than mode. Okay, median will be somewhere in between. Okay, median is more matured, more patience, think and move. Median is like, oh, you got a value, suddenly, increase or decrease. You have all the values like 5,000, 5,000, 5,000, 6,000. Suddenly you get 5. Your average will drop drastically, isn't it? But median you will not see that, okay? Just because, one or two values have come, it's not going to change by much. Okay, so median is more stable. That's why median is always between mode and mean. Median is always between mode and mean. In positively skewed graph, median is on the positive side, right side. Okay, in negative direction. Okay, negatively skewed graph, your median is on the left side. Mean and median is on the left side. Okay, same side where the tail is growing. Okay, so this is what we call as skewness, and you can calculate the formula. You can use this formula to find how much skewness it is. Okay, so we were talking about measure of central tendency to know how far the data is from the center, right? Now we talk about measure of variability, how much variable it is. Of course, we use mean, median, mode. Okay, not mode so much, but yes, mean, median. But we have a different statistic, a different formula, which tells us the variability. We call it as standard deviation. We call it as standard deviation. Okay, so today we'll just talk about it. Next class, I'll show you how to calculate the standard deviation. Okay, so here to understand that, we have to talk about range, interquartile range. Okay, so range is maximum minus minimum, max value minus minimum value. Okay, interquartile range, we have done this when we are doing box plot, isn't it? So, you have 25% data, 25, 25, 25, four groups is containing 25% of the data. If data is 100, you will have 25, 25, 25, 25. If data is 1,000, you will have 250, 250, 250, 250 data, right? That's what we call an interquartile range. Okay, you can read all these. Okay, you know what these are, and then you talk about in this one we have done it, so I can skip it, isn't it? This is what we did. Lowest value, my highest value. In between you have Q1, Q2, and Q3. Q2 and median, they are same. Median comes when you have whole data, right? 100% of data, and you divide into 2 parts. Quartile Q2 comes when quartile when you are dividing it into 4 parts. So the mid part, okay, will be same, isn't it? So whether you talk about Q2 of quartile or median of a data set, it will be same. It will coincide. Okay, so here, okay, so this is how a negatively skewed graph box will look like, and positively skewed graph box will look like. Positively skewed, tail is going on the positive x side. Negatively skewed, tail is going on the negative x side. Right? So box plot will also have something like this. Okay, outliers, right? We discussed this before, right? So you can quickly move across all these. Okay, so yes, I'll send you the link. You can read through this. Okay, now we talk about variance sample. So we'll talk about sample variance later. First, understand what variance is. Then we'll talk about how sample variance and population variance are calculated. Okay, so we'll do this in the next class. So what is variance? What is standard deviation? How to calculate? Okay, so we'll do this, and then based on that, we'll talk about leptokurtic, mesokurtic, and platokurtic. Okay, so this is what we'll do in the next session. So once we do that, okay, the next topic would be So all these things we will not be doing. Okay, once you understand this, we get into probability. We'll do a little bit of probability. Okay, so next class I'm looking to finish the statistics. We'll do a little bit of probability. Okay, little bit of probability, not much. And then following class we'll do regression, one class, and second class. So I need at least 3 more classes. Okay, so next class we'll finish statistics a little bit, and we'll study probability and probability distribution. Following class we'll do regression. After that we'll do classification, and we will end. Is that fine? And of course, if you need any help, you need anything, any suggestions, any help, okay, you have any doubt, I'm going to do that. Okay. So even let's if I have to extend to 4 or 5 classes, I'm ready to do that. Okay. But you have to come to me with what should I do, isn't it?
Okay.
Sound good? Sounds good?
Yeah.
Yeah.
Okay, then we'll end it here. And I'll share this.
Can you send? Can you share this document?
Yes, I'll do that. I'll definitely do that. Okay. I'll do it immediately after the session. I'll share.
Thank you.
Okay. Take care, everyone. Bye.
Thank you.
Thank you.